Okay, so let us now do question 5 together. Hopefully you gave it a go and hopefully you got it correct. But let's look at it anyway and see what we can do with it. So we are told that we need to sketch the graph of this for my domain, which is between 0 and 8 pi, showing all axis intercepts in exact form and endpoints. We also need to state the amplitude and the period. Let's get to it. The very first thing I'm going to do when I need to sketch something is find my amplitude. And I know that my amplitude is simply going to be the number in front, but always make sure that you take the absolute value of it, which means it's going to be 2. Next, I'm going to find what the period is. How do we find the period? Hopefully you all know. I'm going to go 2 pi over whatever is in front of my x. So in this case, it's going to be 1 over 3, which is the same as 6 pi. The next thing I'm going to do, this is something that I really like to do, it is find the x scale. What is the x scale? Take the period and divide it by 4. When we come to sketch it, you're going to see how helpful this is. So the period is 6 pi, and I'm going to divide it by 4, which means I'm going to get 3 pi over 2. Next, I'm going to ask, do I have any horizontal shifts? I do not, because I have nothing plus or minus within the brackets here. But I do have a vertical shift, which I can see here. So my vertical shift is going to be plus the square root of 3. With these key pieces of information, this, and this, and this, and this, I'm now going to be able to give my graph a sketch. Let me zoom in. I'm first going to mark in where the vertical translation is going to occur. It's going to be at the square root of 3, which I know is about 1.7. So it's going to be about here. Normally what I like to do is actually put in a dotted line. So this is where my graph is going to be centered around. So this dotted line doesn't actually exist. I just draw it in to help me sketch it. I then am going to go up and down by my period. So the period is 2, so it's going to go 1, 2 up. So this is going to be the square root of 3 plus 2, and then it's going to go 2 down. So that will be about here. So this will be the square root of 3 minus 2. The next thing that I'm going to do is put in my x scale. So that is how often I'm going up by x. Let me zoom right into this one. And let's remember the fact that my x scale is 3 pi on 2. So I'm going to come over here, zoom right in, and I'm going to start putting in my values. I'm going to do it a bit lower because I know my graph is going to be here, but these are for my x-axis. So it's going to be 3 pi over 2. Now I'm going to plus that each time. So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. Resist the urge to simplify now. Save that as your last step. So then it's going to be 9 pi over 2. Then it's going to be 12 pi over 2. Then it's going to be 15 pi over 2. And then lastly, it will be 18 pi over 2. Now go back and simplify. 3 pi over 2 can't be simplified. 6 pi over 2, that's the same thing as 3 pi. 9 pi over 2 can't be simplified. 12 pi over 2, that's 6 pi. 15 pi over 2, that can't be simplified. 18 pi over 2, that is 9 pi. Now, it's good that we stop here because as we zoom out, we can look up at our domain and we see that my domain is 0 to 8 pi. So it's actually not even going to go to this 9 pi. It's going to stop shy of it. But it's still important that we know that we have that there. It's going to stop before it. So now let me come and put in my points. Now the whole reason why we did the x scale is because we know that my sine graph follows a certain look. It follows a certain pattern. Now let's keep in mind that this is negative sine, so it's going to be going down. So it's going to be going here, then it's going to go down to there, then it's going to go back up, then it's going to go up, then it's going to go back down. Notice that I'm following the x scale here. It's going here, then it's going up, then it's going up, then it's going back down. That is a beautiful graph, if I may say so myself, and I just did. So let's continue. This one down here is going to go back down. Now, where is 8 pi? Where on earth is 8 pi? 8 pi might be up here, or maybe it's not up there, maybe it's down there. We don't know. So what are we going to do? How are we going to find our endpoint? Let me write it down here. What I'm going to say is the following. To find endpoint, always put in these sentences. They help your teachers out so much so that we know what you're doing. To find endpoint, let x equal 8 pi. So in other words, what I want to do is I want to know what my y value is going to be when my x value equals the last part of my domain, which is the 8 pi. So I want to put 8 pi into there to figure out what my y value is going to be. Let's go. So it's going to be y equals -2 sine of 8 pi over 3 plus the square root of 3. And that's, I've written that out correctly, haven't I? -2 sine, yep, that's good. Let me now continue. So I'm going to get y equals -2 of sine. Now we're going to use our symmetry properties. So what I want to do is break this down, and I'm going to say that it's 9 pi over 3 minus pi over 3. So all realize that 9 pi minus pi will be 8 pi. So this is the same as this. And don't forget to plus on the square root of 3. Next, let's continue. Let me rewrite this. This will be y equals -2 sine 9 pi over 3 is the same as 3 pi minus pi over 3, which is going to be plus the square root of 3. Now, if we were to think of my unit circle, let me come over here. Can I come over here? I want to go over there. If we were to think of our unit circle, actually let me just do it over here. My computer's freaking out on me. Let me go over here. Let me draw in that. Let me put that in there. Then let me draw a circle. Perfect. If we were to think of 3 pi minus pi on 3, let me draw what that would be. Well, first I'm going to have 2 pi, which would be there. Then I'm going to have pi, which is going to be there. But then take note that it's going to be pi minus some angle. So actually, it's going to be a little less than pi. So it's going to take me to my second quadrant. But take note of the fact that I can really not even think of that 2 pi. That 2 pi, because it's 360 degrees, just going right around, it's taking me back to the beginning. It's not even helpful to think about it. So all I really want to think about is that this could be rewritten as y equals -2 of sine of pi minus pi over 3 plus the square root of 3. That's really how I want to think about it. Next, what I'm going to do is realize that this is my symmetry properties. And I know that the sine of pi minus an angle is simply sine of that angle. And the reason why I know this red region right here, this angle, that is pi minus an angle. And that's taking me to my second quadrant. And in my second quadrant, sine is positive because sine is like my y value, and obviously my y value is positive in my first and second quadrant. So that means, based on this rule right here, I can rewrite this as y equals -2 of sine, and what this is going to be is pi over 3. So really, it's just that angle there, that theta angle. Then that's going to be plus the square root of 3. Next, let's continue. So I'm going to need to figure out what sine of pi over 3 is. How am I going to do that? Well, I could draw myself a special triangle. So hopefully you've just memorized the unit circle. I think that's really helpful if you memorize it, but if you haven't, utilize your special triangle. So that means this up here is going to be pi on 6. This down here is going to be pi on 3, 2, 1, the square root of 3. So that means sine of pi on 3, here's pi on 3, sine is so, katoa, so, opposite over hypotenuse. So it's going to be y is equal to negative 2 times the square root of 3 over 2 plus the square root of 3. Now, obviously, these 2's are going to go away, which means I'm going to be left with this negative. So it's going to be y equals negative the square root of 3 plus the square root of 3. And that is going to give me y equals 0. So when I have x equals 8 pi, I'm going to get out y equals 0. So let me now come up here and say, hey, this is going to stop here, and that point right there, I'll do it in black, is going to be 8 pi and 0. Perfect, we found our endpoint. It's also important that you mark what this is. Let's mark where we've begun as well, because this could technically be labeled as an endpoint as well. It's where we began, it's our y-axis intercept. It's always safe just to label as many things as possible. And obviously this is going to be an x value of 0 and the square root of 3. That one right there. Perfect. Are we done? We are not done. We still need to find our axis intercepts. Axis intercepts? Axes intercepts. Axis intercepts. Axes, because it was talking about the x and the y, so you had to label your y as well. The English language, it's a marvelous thing. All right, let me come over here, go here. I need more room. I'm going to take all of this, I'm going to shift it over here. Then I'm going to get a line, insert a line just down here, just to separate it. Perfect. Now, I need to find my x-axis intercepts. How do I do that? I know how to do that. It's the rule that we've learnt for many years now. To find x int, let y equal 0. And again, can I please beg you to put these sentences in? They make it so much easier for your teacher. See how I've kind of divided up my work. I've highlighted the important parts. This is what your work should look like. Let's begin. So I'm going to have 0 equals negative 2 of sine of x over 3 plus the square root of 3. Let me now rearrange. I'm going to minus the square root of 3. I'm going to divide by negative 2. And that is going to give me sine of x over 3. Hopefully you can see that these negatives are just going, whoopsie daisy, are just going to cancel, are just going to cancel out. Now I'm left with this. Now, what I need to do is solve a trigonometric equation. I love saying trigonometric. To do that, what I always do is let whatever is inside my brackets here, because it has a coefficient, I do not like it. So I want to let theta equal x over 3. Nothing is special about theta. I could have called it anything, but normally with angles we like to call it theta. So that is going to be the square root of 3 on 2 equals sine of theta. Now I can solve this. I know what sine of what angle is going to give me the square root of 3 on 2. I could come and look at my special triangle and say, look, sine of pi on 3 opposite over hypotenuse, the square root of 3 on 2. So obviously the angle that I'm looking for is pi on 3. Pi on 3 is going to give me what I want. So I come over here and I'm going to write theta equals pi on 3. But obviously there's going to be more than one answer. If I was to come over here and look here. Let me rub that out. When I'm thinking of my sine, I'm thinking of my y-axis, and it's almost like it's saying that it is saying that my y-axis is the square root of 3 on 2. That's the value that I'm looking at. So I come over here, and let me say that this right here, that is the square root of 3 on 2. So that's going to correspond over here, and it's going to correspond over here. And I wish I drew this a little bit higher up. Let me actually redraw it. Should be a little bit higher. I'm just being pedantic. Should be a little bit higher up. Should be like there. 2, let's say the point is, let's go even higher up, you know? If you're going to do something, you do it right. So this square root of 3 on 2 is going to be really up high. It's going to be like up here. It's going to correspond to here and correspond to here. So this point right here, that is the square root of 3 on 2. So I'm going to get an angle here and an angle here. I'm going to get exact values of a half the square root of 3 on 2. And on this side, it's going to be negative a half square root of 3 on 2. So as you can see, I'm getting the square root of 3 on 2, the square root of 3 on 2. I now need to figure out the angles which correspond to it. We know that this angle right here is pi on 3. That is an ugly 3. 3. And I now need to figure out what that angle is going to be. And we know that that angle is going to be 2 pi on 3 because we have memorized our unit circle and know, based on my reference angle, what the corresponding angles are going to be in my other quadrants. So I come over here and I can put in that I have 2 pi over 3. But how many solutions am I going to have? Well, if I come up here and I look, I can count how many x-intercepts I have. I'm going to have 1, 2, 3, 4. I'm going to have 4, which means I'm going to have 4 solutions. So let me find more. And we know that the way I find more, if we were to look at our unit circle, is by doing a full loop and then going back again. So in other words, I'm going 2 pi. If I was to do that again, whoa, what happened to it? I'm going to be going a full 2 pi, then back again. So that means as I come over here, what I'm going to be doing is I'm going to be plussing 2 pi. I'm going to be plussing 2 pi each time. Each time I'm going to be plussing 2 pi. So what is pi on 3 plus 2 pi? Hopefully you're able to do this. Pi on 3 plus 2 pi. Well, I'm going to make my denominators the same. So that's going to be the same as 6 pi on 3 because 3 goes in 6 twice. So that's going to give me 7 pi on 3. 7 pi on 3. Then I'm going to take 2 pi on 3, 2 pi on 3, and I'm going to plus 2 pi to it. That's going to be 6 pi on 3, which is going to be 8 pi on 3. 8 pi on 3. Let me now come here. Let me get rid of that. Let me get rid of that. Now, I obviously don't want my final answer. Let me make that black. I don't want my final answer to be in terms of theta. I want my final answer to be in terms of x, because that's what my question had it in. And because I know that theta equals x over 3, what I can do is rewrite this, but go x over 3, then come here, then come here. I want to take all of this, Control C, go here, paste it, bring it over here. Don't you wish I could do this in class on the board? The magic of technology. That and that are the same because theta equals x over 3. So now I want to get x by itself. So what I'm going to do is times by 3. I'm going to times everything by 3, times everything by 3, times everything by 3. And by doing that, all these 3's are going to cancel. So that means I'm going to be left with x equals pi, 2 pi, 7 pi, and 8 pi. as my x-intercepts. I would come over here and I would put in those values. So my first one, if I was to put an arrow to it, is going to be pi on 0. My next one, let's see if I can make these lines good. My next one is going to be 2 pi on 0. And this one is going to be, what did I say? 7 pi on 0. And we already marked that one as 8 pi on 0. But I'm just that pedantic that I just need to follow this pattern. This should go up here. Let me move these across. Wait, whoop. We're done the question. it needs to be perfect. Whoa. All right, things are falling apart. The wheels are coming off. All right, that's all right. Let me just do this. That is there. We're done. We've labeled all my x-intercepts. We labeled the endpoints. I've done it. We are done. Make sure everything is labeled clearly. We found that. We found that. Hopefully this was helpful in answering this question. Look at all that working out. This was quite an involved question. Hopefully you were able to do it. If you weren't, hopefully this video helped.